For question number 1, we need to look up delta H for the reaction given, keeping in mind that if the reaction is opposite, meaning the reactants and products are flipped from table I, you're going to change the sign on delta H. For our reaction though, you can actually find it right down here. You can see that. And our delta H is positive 53.0 kilojoules. So we're going to report that right here as 53.0 kilojoules. You don't have to put the positive, but sometimes it's a good reminder for when you need to look back at that in order to answer other questions. On to question number 2. Should heat energy be written on the left or right side of this equation? The answer is the left, or the reactants side. And the reason why, since they're asking us to explain, is because the heat of the reaction, or delta H, is positive. When it's positive, that means that heat energy is going to be absorbed during the reaction, so it's going to be one of the reactants. Question number 3. What would delta H be if 1 mole of HI gas had been produced? When we look back up at our reaction above, you'll see that in this reaction, 2 moles of HI are produced. And in the process, we need to use the 53 kilojoules of heat energy. So we're just using this based on 2 moles. So if you wanted to figure this out mathematically, you would say when you have 2 moles of the HI being produced, you used 53.0 kilojoules. And you could set this up as a proportion. They're saying now instead of 2 moles, we want to know what that would take if you only wanted 1 mole. Of course, a lot of you could have just done this in your head, knowing that you're going to be producing half as many moles, you would need half as much heat. So the correct answer for this one would be 26.5 kilojoules. And then I would just use this proportion in order to explain it, but you could also just show me the math. You could say 53.0 divided by 2, and that would explain that one. Number 4, how would increasing the starting concentration of H2 affect the reaction rate? Well, if you increase your reactants, you're going to increase the rate of the reaction. So we're going to say it increases the rate. And your reason why would be, actually, and this is the reason why always, if you're increasing the rate, it's because you have in some way, you've increased the collisions. Because it's those collisions that make the reaction happen. Number 5, how would decreasing the pressure affect the reaction rate? Well, before you can answer that, you need to be sure that you have at least 1 gas in this reaction. And you can see that there are gases, the whole thing is gases. So the only time pressure is going to affect the rate of a reaction is if there's a gas involved. And we have all gases in our reaction. This time they're saying decreasing the pressure. When you decrease the pressure, you're actually allowing those gases to spread out more, so there'll be less collisions. So we're actually going to decrease the rate. And your reason why is we've actually decreased the collisions. All right, number 6. Draw a potential energy diagram to represent the energy changes in this reaction on the graph below. So you need to have properly identified delta H in your reaction in order to know how to draw your potential energy diagram. Your potential energy diagram for this one, since delta H is positive, means that you're going to be going from a low potential energy to a higher potential energy. And then, of course, when you connect the two, you need that hump to represent the activation energy. I was just messing up my line a little there. Okay, so that'll get you 1 credit. This is the way a graph should look if it's endothermic or delta H is positive. The other graph that we've seen before where it starts high and ends low is the one you'll use if it's exothermic or delta H is negative. Question 7. Label the potential energy of the products. If you recall, the y-axis is the potential energy. These were our reactants. These are the products. So the value of our potential energy of our products is going to be this. As long as you went from the 0 line to the height of your products, it wouldn't matter where you drew that arrow. You could draw it over here, and it would still be the potential energy of the products. It's easiest to draw it right here. It makes the most sense. Question 8. Label the activation energy of the reverse reaction using number 8. Now, the reverse reaction means you're going in this direction versus going in the direction you would expect to. So that makes these now the reactants, and in order to activate that reaction to get to the top of this hill, you would just be going from here to the top there. And that is number 8. Number 9, label delta H for this reaction, number 9, using an arrow to indicate the value. Delta H is the change from the reactants to the products, so the difference between the reactants and the products. And again, it doesn't matter where you draw this, as long as your arrow is going between the value you chose for your reactants and your products. We're going to label that number 9. Number 10, draw a dashed line to show how using a catalyst would affect the potential energy changes of the reaction. If you recall, using a catalyst lowers the activation energy so that it's easier for that reaction to occur. So in number 10, all you're going to do is draw a dashed line to lower the hump in your reaction line. All right, each of the questions on the back side of this is going to be based on equilibrium. So this is Le Chatelier. And the conditions are different than the stuff we were talking about on the front side. So make sure you're remembering same side opposite, opposite side same, and more P, less G. All right, number 11. Which side of the reaction should heat energy be written on? So we're going to need table I. And here is table I, and we need to find that reaction, and here it is. I've found it right down here. Is that it? Yep, that's it, but it's backwards. Remember, when it's opposite, see now we have, this is our reactant up here, and these are our products. So that means that your delta H, all you're going to do is change the sign. So instead of that being negative 84, it's positive 84. And when delta H is positive, heat is a reactant. So you're going to say the reactants, or you could just say on the left. And your reasoning could just be, again, that delta H is positive. Now I'm actually going to put heat in here because it's going to make our lives easier later on. Number 12, what effect will increasing the pressure have on the concentration of C2H6 gas? Okay, this is equilibrium. So when we're talking about pressure, we need to remember more P less G. But you need to have at least one gas in your reaction for pressure to have any effect on it at all. You can see right away there's a gas and there's a gas. So we do have gases. And then to figure out which side has less gas, because that's the side that's going to increase when you have increased pressure, you just add up the coefficients of gases only on each side of the reaction. So on our reactant side, since there is no coefficient, on our C2H6, which is a gas, it's 1. And on our product side, we're ignoring the carbon because it's a solid. We have H2 gas, and there are 3 moles of that. So when we have more pressure, the side with less gas is going to increase. So this side is all going to increase, and this side would all decrease. Since they're asking about the C2H6, we would say it increases since that's the side with less moles of gas, and you can actually use more P, less G as your answer. Really, my explanation, my request of the explanation at this point is to make sure that you're not just guessing, because it's either increase or decrease or no effect. Number 13, what effect will decreasing the concentration of H2 have on the concentration of C2H6? So if we decrease this, if we decrease the H2, on the same side, the opposite thing's going to happen. So the carbon will go up, but on the opposite side, the same thing's going to happen. So the heat and the C2H6 will decrease. C2H6 will decrease, and the reasoning is just that opposite side same. Because C2H6 is on the opposite side of H2, so the same thing will happen, which was decreasing. Number 14, what effect will decreasing the temperature have on the concentration of H2 gas? So again, we're going to be decreasing, and it's important that we had written the heat in order to answer this, because they're talking about temperature, and they want to know what happens to H2 gas. Well, here's heat here on this side, and H2 is on the other side. So they're on opposite sides from each other. So opposite side, same. So since we said it was decreasing the temperature, we're going to decrease H2. And again, our reasoning is just opposite side, same. Number 15, what effect will adding a catalyst have on the concentration of CS? When you add a catalyst to a reaction, all it's going to do is increase the rate of the reaction. But because it is at equilibrium, it's going to increase the rate in the forward and in the reverse. So the reaction will be happening more quickly, but everything's going to stay the same concentration because you're going to be making it and you're going to be breaking it down at the same rate, just faster. So we're going to say none. There is no effect on the concentration. And we'll just say reaction in forward and reverse is faster. These last few questions are all referring to the reaction given above. And we're going to look at that on our table I to figure out where heat goes. And here it is. It is positive, so our heat is going to go on the left, and I'm actually going to write that in there. Now down below I did not put all of the reactants and products, and I did not put the heat necessarily on the proper side because you were going to have to look that up. So it might be kind of difficult to follow along. So my suggestion, if you want to do it up above in the reaction itself, that you use pencil so that you can erase it as you're working. All right, number 16, what would happen if you decreased the temperature? So if we decrease the temperature, that's going to be decreasing this. So on the same side of the reaction arrow, that's this thing, we're actually going to do the opposite. So the opposite would be increasing. And on the opposite side, the same thing's going to happen. Since we were decreasing, the same would be that these both decrease. So now to determine the shift, you're going to look at your arrows and decide which side is increasing as a result. And the Nh4cl side is going to increase because it's going to try to replace the heat that's missing, and it will shift to the left. Next, a decrease in pressure. So before we can answer anything about pressure, we need to make sure we have at least one gas, and we don't. We have a solid and we have aqueous, and aqueous just means dissolved in water. So nothing's going to happen. Make sure you mark that in some way so that I know that you answered it and that nothing happened, and not just leave it blank. Next one, removing chlorine. So when we say remove, that's a decrease. On the same side as the chlorine, the opposite thing will happen. So the NH4 plus will increase. And on the opposite side, the same thing's going to happen. So those are going to decrease. And then we look at our arrows, and the side that has the up arrow is the right. So the shift is to the right because it's going to attempt to replace that Cl that was removed. Number 19, adding NH4Cl. That means increasing the concentration of NH4Cl. On the same side, the opposite thing's going to happen, and heat's on the same side as the NH4Cl. So that's going to decrease, and on the opposite side of the reaction arrow, those things are going to increase. So our shift, the things that increase, are on the right. And the last one, adding NH4 plus, so that's increasing this. On the same side, the opposite thing will happen, so the chlorine's going to go down. And on the opposite side, so that's these things are opposite the NH4 plus. These things are going to do the same thing, so they're going to increase. And those things that are increasing are on the left.